Express.js is a minimalistic web framework for Node.js applications. With a relatively small set of features, it provides you with everything you need to build an API or web application. At the same time, it doesn't impose any specific patterns, giving you the freedom to decide how to structure your project.
I want.
This flexibility and lightweight nature are the key reasons why it remains one of the most popular packages on NPM. By the way, if you want to learn more about Node.js and NPM, I have a video about it. Feel free to check it out. So without further ado, let's dive in. First, we start a new project with npm init, and then install Express. Now when we have it, we need to create a file where we will actually write some server code. As I mentioned before, Express doesn't enforce any rules on how exactly you should structure your project, so you can name this file whatever you want. People often call it app.js or server.js. I think server speaks for itself, so let's use this name. Okay, so first we import Express, and then we create an instance of it, which is basically our application, the thing we will use to define routes and handle requests. To make it start listening for those incoming requests, we can use .listen method. As the first argument, we provide the port number, for example 8000. The second argument is optional callback function, which runs when the server starts successfully. In our case, we can just log a message to let us know that everything is working as expected. Now let's see how we can handle different HTTP requests. It couldn't be easier, because Express has built-in methods for each of them. All of those methods have the same structure. First, you use the corresponding method, like post for post requests or get for get requests. Then, as the first argument, you provide the endpoint which you want to handle, for example, root URL. Then, as the second argument, we provide callback function with two parameters, request and response. Inside this function, we define the actual handling logic. For example, we can use response send method to return hello world. Let's test it, shall we? File is saved, so now we can run this server. We can also add watch flag to make it restart automatically when we make any changes. As we can see, if we navigate to root URL, we get back hello world. Now send is very versatile. It will automatically detect the type of data we are sending and will modify the response accordingly. For example, in our case, we are passing a plain string, so it will set content type of response to text HTML. That's why I can wrap hello world in h1 tag and it will be displayed accordingly. If you want to respond with JSON instead, you can also use send, but a better option would be to call the dedicated method. It improves readability and makes sure the edge cases like sending non-object values are handled properly. Now, with Hello World example, we could see that the string we provided was sent as HTML. However, most likely in real-life scenario, you would want to send an entire web page instead. To do that, we can use another method called sendFile. This one expects absolute path to the file, and this raises two questions. Where do we store those files, and how to get the absolute path to them? When it comes to static file storage, a common practice is to put them in folder called public. So let's create it, and then put some static HTML file in there. Now, how do we get the absolute path to it? The answer depends on format you are using, CommonJS or ES modules. Right now we are using CommonJS, and that's why we have access to very handy variables like file name, which store paths to the current module, and dir name, which holds the path to the parent directory. Now we can import built-in path module and use join method, which takes different segments and returns properly formatted result. In our case, we need to start from parent directory, then go to public folder, and finally the file itself. Now let's use it in our request handler and save the changes. As we can see, works as expected. However, if you are using ES modules format, a bit of extra effort will be required. Let's change the type to module in package.json and then replace all required statements with import keywords. Now, when everything is in order, we can save the changes and see the problem. Unfortunately, dir name and file name variables are not available for us in this format. There are two solutions. You can use an experimental feature and simply replace dir name with import.meta.dirname, which serves the same purpose. As of today, it's in release candidate status, so most likely it will become stable very soon. However, while it's not officially released, there is another widely used solution. There is import.meta.url property, which is a stable feature, but unfortunately returns data in a wrong format. We can fix it using method from another built-in module called URL. This will give us the absolute path to the current module, just like file name variable. Now we can use path.dirname method to get parent directory. As you can see, this solution requires some extra code, so let's hope those experimental features will be released as soon as possible. Now, since we are talking about handling static files, I wanted to cover one more thing. Right now we are serving a single lonely HTML page. Let's create another one, for example, about page. Now, in order to return it, we have to define another request handler, which essentially does the same thing. If we have a lot of static pages, you can imagine that our code can become repetitive and cumbersome rather quickly. In addition to that, there is another problem. If such page has some dependencies, for example a script file, we're gonna need a route handler for it as well. Let me show you what I mean. We can create a new folder called JS and then put some script file in there. Then in about page, I will add a script tag referencing it. Now when about page is loaded, instead of executing the script, we get an error. This is happening because we didn't define the request handler for the path to the script. When browser tries to request it, server cannot find anything, so it returns standard HTML error page. The second error appears because under the hood browser requested JavaScript, but got HTML with error message instead.
What's that, brother?
So how can we solve all of these problems? It's really easy. All we need to do is to set our public directory as static folder. We can do it with the help of Express built-in middleware. Middleware is just a piece of logic, a function that sits between request and response. We will talk more about them and even create our own a little bit later. Now, in order to add it to our application, all we need to do is to call use function. It takes two parameters, path for which middleware is supposed to be executed, and the middleware itself. If you skip the first argument, it will default to root URL, meaning that it will be applied to all requests. This is exactly what we want. Then we use already mentioned built-in middleware by calling express.static method. As the argument, it takes the path to the directory which we want to define as static, which is public in our case. Now let's remove all request handlers and test if it works. As you can see, it does. Though there is one technical caveat that you could notice. As you can see, we need to add .html in URL. To fix it, we can set extension fallback. Basically, we are saying that if nothing is found, try the same path again with provided extensions appended. As you can see, works as expected. All files inside public folder are accessible. Just remember to not put any sensitive data in this folder because, as the name suggests, it is available to everyone on the internet. Okay, now when we covered static files, let's talk a little bit about dynamic pages. Sometimes you want your content to change depending on circumstances. To achieve that, we can use template engine. There are many different options, but one of the most popular choices is EJS. So let's install it. Great, now in order to inform Express that we want to use a template engine of our choice, we can use app.set method. There are many different settings we can configure, and one of them is called view engine. So in our case, we say that it's gonna be EJS. Great, now there is also a setting called views, which defines the path to the folder where our dynamic pages are stored. The default value is folder called views inside current directory. Most people keep it this way, but if you want to store them somewhere else, you can set the different value. In our example, let's use the standard approach. I will delete this line since it will be set by default. And then I will create a folder called views, inside which I will create a new dynamic page. Let's call it profile. Simplicity is one of the key reasons why EJS is so popular. The syntax kind of looks like PHP. So let's type welcome, followed by username, which we will provide. Now let's open our server code and say that if user navigates to /profile, we're gonna serve him this dynamic page. To achieve that, we need to use .render method, which will take two arguments. First is the path to the dynamic page we want to render. Since it's going to look for it in views folder by default, we can give it just the file name. Then we can provide values for variables used in that dynamic page. In our case, we have just the username. In real life scenario, it would be queried from the database, but this is just an example, so let's hardcode some value. Now, if we save the changes and go to profile, we can see that it works as expected. Okay, now when we have discussed all the different types of data you can send back, let's focus on the actual request response cycle. Let's imagine that we are building an API which manages database of users. For simplicity, we can just hardcode some values. Now, we probably want to be able to query those users, so let's define a new handler for that. So we can say that if we navigate to users, we want to return all of them. Let's save it and test it. Now, returning all users can be too much, so let's say that we want to add a limit. We can do it by inserting URL parameter. In our server code, we can access it with the help of request.query, which returns an object that contains key value pairs from the request we made. Important detail is that by default all values from that object are treated as strings, so in our case we have to convert limit to integer first. After that we can use it to return only a certain number of users. It is also worth mentioning that whenever you deal with user input, you should always be cautious and implement some kind of sanitization process to avoid SQL injections and other types of malicious code. In our case, let's add some basic verification checking if limit is indeed a number and is positive. If there are any problems, let's return the entire list. It's also important to mention that sending the response doesn't stop the code execution, so to make sure we don't get an error, we can add return keyword. Okay, let's save it and test it. As you can see, when we provide the limit, we get only the requested number of users, while in the case of wrong value, we get the entire list. Now, what if we want to get the specific user? For that purpose, we can use dynamic parameter. All we need to do is to prepend it with colon, and then we can access it in request.params. Just like request.query, it stores values as strings, so we have to convert it to integer. Now, there is one more thing I wanted to cover. When you send the response, Express automatically assigns 200 status code to it. But what if we have some kind of error? Luckily, we can easily set it manually with .status method, which is also chainable, which means that we can set status and send the response in one line. So let's add an if statement and say that if parseIn returned none, which means that provided ID was not a number, we return bad request status code and send some error message. If there is no problem with ID, let's try to find the user. If we didn't find anything, let's return not found status code with some error message. And finally, if there are no problems at all, let's return the requested user. And even though it's not needed, we still can explicitly set 200 status code for readability purposes. Let's test it, shall we? So if we provide the correct ID, user is returned. If there is no user with such ID, we get not found error. And if ID is invalid, we get the corresponding error message. Now, there is one more detail I wanted to cover. In Express, order of request handlers is important. Let's say that we want to add a new endpoint which returns all names of all users. Now, if we save it and try to test it, suddenly we get an error. The reason this is happening is because endpoint with dynamic parameter is above that new request handler that we just defined. So whenever any request is made, Express goes from top to bottom looking at every route and checking if it matches or not. So if we request user/names and this handler with dynamic parameter is encountered first, it's going to match because dynamic parameter doesn't care what value is provided after users. It simply grabs anything that is there. And so, according to logic, user/names is also supposed to be processed by this handler. If we swap those handlers, save the changes and refresh the page, we can see that now everything works as expected. So remember to pay attention to the order of your handlers. Okay, now let's add a post request handler which will create a new user. But first we need to add some middleware. You see, when someone sends some data with post request, they usually do it either in JSON format or as URL encoded data if they are using HTML forms. By adding middleware which parses those two formats, we can easily work with them by accessing request.body object. So we need to say that our application is using JSON and URL encoded built-in middleware. In case of URL encoded, we also need to explicitly set extended property to false or true. Basically, if it's true, we can work with nested objects. In our case, we don't need it, so we can set it to false. Now, when we have it, we can access request.body, which will store the data that we receive. So let's create a new user, add it to our improvised database, and then send the list of all users. Now let me open another terminal and use curl to make post request. First, let's test JSON format. As you can see, the new user was added. Now let's do the same, but this time use URL encoded format. And again, a new user was created. Great, so it looks like everything is working. Okay, so let's finally look closer at middleware. So we used quite a few built-in ones already, but what if we want to create our own? It's actually really easy. All we need to do is to create a function. For example, let's create logger, which will print out information about requests. Now, we can do it right here in server.js, but the good practice is to keep them in a separate folder called middleware. Let's create logger.js, inside which we will define a new function. It will take three parameters: request, response, and function called next. Now, inside we can console log request method and URL. After that, we call next function, which will give control to next middleware. And that's it. As I was saying, middleware is just a piece of logic that sits between the request and response, having access to both, and when it's done, Express goes to next function. Now let's export our logger. Then we can import it in server.js and use it just like we did with built-in functions. Now we can make a few requests, and as you can see, the information gets printed into the console. As I was mentioning before, you can also specify the path for which the middleware function must be invoked. If you don't do it, then it will be root by default, meaning that it will work for everything. But if we say that it should be invoked only for users route, for example, then it will work for everything that starts with /users, while everything else will not be affected. Now, one more thing I wanted to cover is order of applying middleware, which matters a lot in Express. All this time we were using them at the top of the file, because we wanted for them to work globally for all requests. And that's how you usually want your middleware to work, because if you type app.use somewhere in the middle of your file or at the bottom, all request handlers above will not use it. Let's test it. I can move useLogger line a bit lower, and now if I make request to endpoint above it, it will not fire, while all others which are below will still work. Okay, now one more way you can use middleware is to apply it to a specific request handler. In this case, it will work only with endpoint from this handler. It's also worth mentioning that you can stack as many middleware functions as you want. For example, if I add logger twice, the information will be printed out 2 times. Now, obviously, order of using middleware itself matters as well. For example, if I go to our logger and change the message to log1, and then create a copy of this file, call it logger2 and print out log2, then if I say use log1 and then use log2, and then make some request, then log1 will be executed first and then log2. If I swap those two lines, middleware also will be invoked in different order. Okay, so we almost finished. One more thing I wanted to cover is router. As you can see, even with such a small app, managing just one object like users, we've already accumulated a significant amount of code. As the application continues to grow and new objects will appear, the server.js file will become increasingly cluttered and harder to manage. To keep things organized, it is a good practice to create a separate directory called routes. This folder is used to keep route definitions, grouping them logically by feature or functionality. In our case, we can group all user endpoints in one file. Let's call it users. Now we can cut all of our user endpoints and put it in this new file. At the top we import Express, and then we create a router with express.router method. You can think of router as mini application. So now we need to replace all app instances with router. Then at the bottom we export it. Then we go back to our server.js file and import it. Now we can invoke app.use just like we did with middleware. But this time we actually want to specify the path. Basically, we are saying that everything that starts with /users should be handled by this router. Now, because of that, there is one more thing we need to fix. We need to go to this router file and delete /users from all endpoints, because it will be automatically prepended by router. Now, if we save it and make a few requests, we can see that it still works, but this time our project is much more organized. Well folks, that's all you need to know to start working with Express. I hope you liked this tutorial. If you did, please leave a like, a comment, and subscribe for more. Cheers!